All right, so the last thing we're doing. Okay, so let's kind of put this all together. Okay, so again, step one, you have your neuron at the synaptic cleft attaching to a muscle cell, right? So remember, you have this action potential building up, right? You have all these sodium ions entering the cell. You have all these potassium ions leaving the cell. That's going to cause your action potential, right? That electrical charge from the neuron is going to go down to the end of the axon terminal. It's going to open and close those pumps at the synaptic cleft, and you're going to release that acetylcholine, that ACH. So you can see the acetylcholines getting released at the cleft. That chemical messenger, the acetylcholine, that neurotransmitter, is going to bind to these receptors on the muscle cell. It's going to cause a signal to be sent from down the T-tubule of the muscle cell all the way through that sarcoplasmic reticulum. Again, that kind of thin web wrapped around the muscle cell. So you can see all the calcium ions are in the SR, right? Now that you have that signal, it's going to cause these pumps to open up, and now all that calcium is going to go into the sarcoplasm where your thick and thin filaments are. So all this calcium is going to bind to the troponin, and now that's going to cause the tropomyosin to open up, and now you're going to have all these actin binding sites open, right? So now all these actin binding sites are open. The myosin heads with ATP can form your cross-bridge attachment, and they're going to slide those thin filaments together, which is going to shorten the muscle during contraction. So now when you want to relax your muscle and your muscles are relaxing, that calcium is going to dissociate. The tropomyosin is going to wrap around and, again, block those actin binding sites. Myosin is going to dissociate. Calcium is going to go right back into the SR where it's stored. Obviously, with rigor mortis, you're not going to have ATP, so the calcium is going to be stuck here, and it's going to be permanently stuck in this state. So that's putting it all together. Okay, so here's what you're doing for the lab for 2 days. So, in this lab called rigor mortis models, you're doing 3 things. 1, you're going to go to step 3. You're going to draw your rigor mortis models. Remember that picture I said take a picture of? You're going to show the sliding filament theory, which means you'll have the muscle relaxed, and you're going to show a contraction together, and you're going to explain that in this space right here with the drawing. Then you're going to answer question 4 right here, and then once you're done that, just answer the 8 conclusion questions. Okay? So that's all you're doing for the rest of the class. Okay?
So what happens when you have a cramp in your muscles?
So what happens is when your muscles are not getting enough oxygen, that means are you doing aerobic or anaerobic respiration? Without oxygen. Okay, so if you remember, an aerobic brings lots of ATP. Well, if you have fermentation, anaerobic respiration, you're getting a lot of lactic acid. So when you have lactic acid buildup, it's going to cause the pH of your muscles to decrease, and you're going to wind up with a lot of cramping.
Oh.
Yep.